Hey, the purpose of this video is so that you can prepare for a retake on all or part of the energy resources quiz. And I want you to use this to help you fill out a perfect copy of the part or parts that you need to retake. So our first standard, they are standard 17 about the consequences of global warming. Um, there's really only one question there, a three-part question. And so you can list any consequences of global warming, but keep in mind that you just can't say something like this, the earth getting hotter. Well, that's more of a definition than a consequence. So earth getting hotter, what is the result of that? So here are three that I picked, but then I'll talk about other ones you can have. So melting ice causing sea level to rise, flooding coastlines, is definitely one. Notice it just doesn't say flooding, it's the sea level rise causing flooding. Farmland has shifted, agriculture has been impacted. We know winters are coming later. We're having earlier springs, and that's actually not good for fruit crops because they can freeze easier with that spring coming earlier and the blooming sooner. Tropical diseases spreading. One thing from our image analysis was more aggressive poison ivy. Other things from the image analysis, hot water being bad for fish, for example, an increase in forest fires, an increase in severe weather and billion-dollar disasters. Those would all be examples. So there's many to pick from there. Now, on the retake for Standard 18, there will be a little tiny change in the questions, but mostly the questions will be the same. So here's your answer to the first one on Standard 18 about classifying energy resources. A resource that can replace itself is renewable. A resource that will never run out is called perpetual. Okay, question 3, crude oil is a fossil fuel in the form of a liquid. Keep in mind another word for that is petroleum. Now, next up here, number 4, the only solid fossil fuel is coal. And number 5 is a tricky question until you really go, oh, wait, a nuclear power plant, there's going to be no burning of coal. Instead, that is splitting uranium atoms. So no coal will be involved at all. Okay, next up, I have to sneeze. Okay, sorry. Wait. Sorry. So I think that's it. Next up, question number 6. It says, which of these is actually a type of solar energy? That is wind energy. The sun heats unevenly, and that's when we get these warm and cold air masses with different air pressures. So wind is really a type of solar. And then the final question on the front side, a lot of poor countries depend on biomass. When we think that through, that's using things like firewood and also, honestly, animal waste, dehydrated animal waste for energy, and that would be cheap. So a lot of poor countries would depend on it. Okay, now as you flip in your packet, all of the following are perpetual energy resources except nuclear. Nuclear, again, is uranium, and uranium is found in rocks. It's a mineral building block of rocks, so that would be actually a non-renewable. So wind, solar, and hydroelectric are perpetuals. Okay, so here comes the part that's going to change on your retake. Everything else will be the same questions except this. I'm going to change up the resources. So sunlight is perpetual, coal, non-renewable, water, perpetual. You won't have those same two perpetuals. There'll be different ones to think about, but what your mind has to do is, okay, which of those 6 would always be there? Fish and trees can reproduce, making them renewable. And uranium is a non-renewable resource because remember, it's found in rocks, can't reproduce. Okay, now our next step here, we get to this graph, and keep in mind that this graph is actually 2010, so a while back here. And my first question is, what percent of our energy came from fossil fuel use? So what it requires you do is go through these 5 pieces of our energy plan back in 2010 and think about, is that a fossil fuel or not? So renewable, definitely not, because fossil fuels can't reproduce. Nuclear, that's uranium. Natural gas, yes. Petroleum, that's fancy for oil, yes. And then coal. So is a yes. So when I look at those, notice I have arrows coming in to those 3 pieces. You may want to do that on yours or add stars to it. When I add those 3 pieces together, I get the coal, oil, and natural gas, I get 83%. So in 2010, 83% of our energy use in the US was based on fossil fuels. Okay, now, which section of the renewables is similar to burning a fossil fuel? So now we're like, okay, this 8% renewable in 2010, here's how it broke down. So I'm not calling these a fossil fuel. And by the way, I know this graph, we say perpetual for a lot of these, they're saying renewable. So let's go through. Does wind energy have anything to do with fossil fuels? Mm-mm. Solar? Mm-mm. Biomass? That's burning trees and poop, living things. Fossil fuels come from living things. Earth's heat, geothermal? No. And hydroelectric, remember, that's falling water. So the answer to that last question on the back of page 1 is biomass. Now, here's why it's similar. So, biomass is similar to burning a fossil fuel because it's burning a living thing, and all living things are made of carbon. So, when they're burnt, it creates CO2. If you want to shorten that, I'm okay if you just say it creates CO2 or it comes from a living thing, but that's the full explanation. Okay, now if you'll please flip to the next set of questions, the graph has changed. So now this is not showing 2010 anymore. It's 12 years into the future from 2010. It's showing 2022. And we can see that the percentages have changed, which makes sense, right? Societies change in their energy plans over time. So here it is again. I've put little stars in our 3 fossil fuels. So petroleum again is also oil, known as the same thing there, coal and natural gas. And then when I add those up, notice it's down to 79%, and it used to be 83%. Now, here comes standard 19, and this is about your ability to understand how energy resource choices impact global warming. Okay, so I know this is a little tricky wording, but in 2022 compared to 2010, fossil fuels went down. Okay, now is that good or bad for limiting global warming? Well, less fossil fuels, less carbon dioxide, so it would decrease global warming. You don't have to get this wordy, but I am looking for a certain gas. When we burn a fossil fuel, it puts CO2 in the air, carbon dioxide. So less CO2 when you burn less fossil fuels. Okay, now let's look at the piece of the puzzle, or the pie, I should say, for nuclear. So back in 2010, nuclear power was 9%, but now, or closer to now, nuclear power is 8%. So nuclear power actually went down also. It decreased from 9 to 8. But that is actually bad for limiting global warming. And here's the reason. Nuclear power is not a carbon-based energy source. It's uranium. And so when uranium atoms are split, no carbon dioxide is produced. Now, I know there's a radioactive waste issue to deal with, but no carbon dioxide is given off at that kind of power plant. And then finally, we're comparing the renewable piece. So in 2010, renewables were 8%, but in 2022, the renewables were up to 13%. So in 2022, the renewables definitely increased, which is good for limiting global warming. Now, notice this. Again, carbon dioxide, right? That's the gas we're thinking of for global warming. Most renewables, we also call them perpetuals, create no carbon dioxide, but biomass is the important exception. But you'll notice by 2022, biomass was less than half of those renewable sources. The other perpetuals here that this graph is calling renewables outweigh them. So that would be a good thing to see this increase in those renewable/perpetual resources.